chapter 12 today. As far as new material goes, we will be doing lab 34 on Thursday. Okay, everybody listen. 34. 3-4. It's a DNA lab. It's actually pretty cool. So it is the 20th today, right? Yeah. Alrighty, so it is 6th period. Yeah, your lab 5 should have been in that box on Monday. Friday. Whatever, didn't I say that? Yeah, if you're not, they need to be in that box ASAP, okay? Alright, so it is chem. It needs to be focused. Alrighty, so it is chem 11:10, chapter 12, day 3. Our objective is going to be able to name cyclical structures, what is the word I'm looking for? Let's just call it this. We're going to write halogenation and go from names backwards. There are a couple I've noticed on the test where they gave you the name and want you to figure out what its skeletal structure looks like. So we are going to do that. Now, as far as cyclical structures go, they're pretty easy. You simply add cyclo to the front. Okay? It's like if I did this, okay, how many carbons are there? 5. So it would have been pentane, but because it's now a cyclical structure, it is cyclopentane. Okay? Now, cyclos do what they refer to as take precedence. Okay, does anybody know what that means? To take precedence? No? It means I name it that no matter what it is. So if I have this, let's say I had that. Okay? Now, no matter what, this is a 1, 2, 3, 4, 5, 6. This is a hexane, right? This is a, what is this? This is a cyclohexane. Okay, this is going to be what I name it. Now, there's a whole bunch of rules that we'll learn here. Okay? You always start, like in this one, it doesn't matter because there's only one branch. If there were multiple branches, I always start numbering at a branch. Just like in a linear, I started numbering where the one that branched the soonest, right? In this one, it would simply be hexane, cyclohexane. Okay? Now, if there was if there were two branches, then I would number the branches. But in this one, there's only one. So if I had, let's say I did this. Oh, what did I screw up there? Anybody notice what I screwed up there? This is a branch, right? What should that have been? Sound louder. Hexyl cyclohexane. Because it's a branch now, right? Hexyl cyclohexane. Okay, so let's say I did this. Let's say I did that. Okay. Now, this is methyl. No, this is ethyl, right? This is ethyl. This is propyl, correct? Now, if you have a choice, you always want to start the numbering with whatever is going to start the name. So I've got a choice. I can go 1, 2, 3, or I can go 1, 2, 3, right? Well, which one's going to come first when I name this? The ethyl is, right? So I'm going to make that my 1, my 2, and my 3. Then I'm going to name it just like I would have named it before, other than this takes precedence. So when I'm done, what do I know this has to be? Well, but just what is this going to be when I'm done? It's going to be a cyclopentane. Why hell, I can't think today. Cyclopentane. So it would be 1-ethyl dash 3-propyl cyclo. Oh, shit. I cannot write or think straight today. Cyclopentane, just like that. That makes sense. Now, the one on the test, I think there might be two. They're really straightforward, so they're not a big deal. Okay? Alrighty. Now, what I'm going to do is, who remembers what an isomer was? Same formula, different. I like either one. Let's go with your second one, arrangement, right? So what they're going to do is they're going to do something like this. They're going to do that, and they're going to say, are these isomers? Okay? Well, how am I going to figure out whether or not they're isomers? Anybody know? Yeah, I'm going to go and see if they have the same what? Well, what did we just say an isomer was? Same formula, different arrangement. Are these arranged differently? Yeah. Okay. This is an aldehyde. I believe this is a... Yeah, we don't know what this is. This doesn't qualify as one of those functional groups, right? Now, what is it? How do I find the formula for this?
For the first one?
Yeah.
Just count C0 then.
Okay, so I'm going to have C what?
5.
C5.
O1. And then hydrogen.
Okay, I will always go at the end. So how do I figure that out? How do I know how many H's I've got? You know, I'm just going to go and like do this and figure out how many H's I've got. Are there any H's right here? Why not? It's already got 4 bonds, right? So you got C5, I got H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C5, H10, O. Okay? I'm going to come over here and I'm going to figure out what it is, right? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. C5H11O. Are they the same things? No. So are those isomers? No. Okay. There's a couple of them on the test. Just count them up. Do the math. If they're not the same, they're not the same. Now, one thing you have to watch out for is this. Let's say I did this. I did that. Are those isomers? No?
Oh wait, those are the same thing.
Say that louder, Criddle.
They're the same thing.
They're the same thing. Why are they the same thing?
It's just like, look,
Yeah, I've just mirrored it, right? So no matter what, they're the same. So they're still not isomers. So be careful with that. Okay? Alrighty. Now, what I want to do is we're going to do this two ways. I'm going to give you a name, and we need to come up with both the condensed structure and the skeletal structure. Okay? So this is what I've got done. I've got 3-ethyl, 3-ethyl, dash 2-methyl heptane. Okay, so who could tell me how they think would be best way to figure this out? How would be the best thing to do here? Should we go to the condensed? Say it louder, Richards. What?
I would do skeletal.
I would do skeletal first too. So what am I going to do? I'm going to draw a heptane, which means I've got 7 carbons, which really means I only have 6 lines, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I got my 7 carbons, right? Then what do I got? Off of my 1, 2, off my 3rd carbon, I've got 2 branches, right? And then off of my 2nd carbon, I've got 1 branch, right? Now, there's a couple of different ways I could write this condensed. Okay? So, right here. See that carbon right there? What's that carbon bonded to? Doesn't it have 1 H? Remember how a lot of them we had like a C and an H like this? And then I would go CH3 taken twice. And that gets me to right there, right? Because those two are bonded to that carbon that's bonded to that H, right? And then I've got a what? What's going to come next? Isn't that another CH? But that's also bonded to a CH2. Now, what would be probably the best way to draw that so I know it's a branch? I would probably do this. Like that other way. Remember that other way I showed you last time with the little line telling me that on that carbon right there I've got this other branch? Because didn't we do a couple of these last time? Okay. And then I can just go finish this out, right? So from there, I'm going to have 1, 2, 3, what? So I could go CH2, CH2, CH2 like that. Probably the easiest. What could I have done? CH2 taken 3 times, then I've got a CH3 at the end. Okay? Yes. Did you have a question, Gary, or were you just fixing your hair? Oh, okay. So they're going to ask you to do both things. Not on the same question, but ultimately you're going to have to go from a name to either a skeletal or a condensed. Okay? Now, I want to go raisey handy on this one. Okay? Now, I do need to do something really quick before I go on. I just remembered. The other day, we screwed up. And I say we because I don't know if it was me or if it was you, but I didn't catch it until I got to my next period. No. That's not right. Because we have it right. It must have been my 7th period. Never mind. Alrighty. So, this is what I got. I got 4-ethyl dash 5-propyl nonane. 4-ethyl dash 5-propyl nonane. And I want both skeletal and condensed. And I want 8 hands. Skeletal and condensed with 8 hands. Just give it to me. Is that like now? Oh, I would hurry down and hurry back. One, two, three, four, halfway, five, six, two more, seven, one more, eight. Alrighty, who is four? Okay, Garrett, what do you got for the skeletal? Just zigzag me here.
Okay, yeah, so zig, zag, zig, zag, zig, zag, zig, zag.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I know it's a no-name, right?
Yep.
Okay, then where?
And then on the fourth from the left,
So you went 1, 2, 3, 4.
I did an F also, two, like a zigzag.
2 like that.
And then on the fifth one, I did a zigzag.
3, 4, like that. Is he right? Alrighty, now, so there's that. Now, when I go to write this, I would probably do it the same way we just did it, right? So right here, I'm going to have a, well, actually, you were 4. Who was 5? Okay, what do you got for me, Hannah?
Okay, I'm not positive.
That's all right.
Correct. So I have CH3, and then CH2 taken twice, and then CH, and then branching off of that, I have CH2, CH3,
Okay,
and then CH,
okay.
and then branching off of that, I have a CH2 taken twice, and a CH3.
Now, I will tell you this right now. They will write it like this every time. I don't know why, but they will. They'll write that out. Okay, and sometimes, because what I have noticed is that, remember in the last chapter we talked about there was condensed and then there was what? I remember what that next thing was called. There was condensed, then there was like super condensed, you know what I mean? They usually will not do this, and I'm not sure why, but they will write these out. I mean, I'm cool with this as long as you understand, you know what it means. Do we all understand that? Okay, then what do you got for me?
Okay, so then I have a CH2 taken 3 times, and then a CH3.
Does that work? Yeah. And I think the reason they do that is that they don't want you to confuse this with being branches, maybe. I don't know. I really don't know why they do that. But they will usually write these out when they do it this way. So, is that making any sense? Yeah? Should we do one more? Yeah? Alrighty, so let's go with 3, 3 dash dimethyl dash 5 dash propyl decane. So 3, 3 dash dimethyl dash 5 dash propyl decane. What does dec mean? 10. Okay. So now we're going to go with 10 hands. 10 hands. And again, I want both skeletal and condensed. One, two, three, four, five. Halfway there. 6. 7. 3 more. 8. 2 more. 9, 10. All right, Krill. You went to the source. Were you in a good position?
I just forgot to put one C, but yes.
Okay, so zigzag me skeletal.
Alright, so zig, zag, zig, zag, zig, zag, zig, zag, zig. And then on the third one over,
Okay.
you do one up and one down.
Okay, now one thing you will see sometimes is you will see this. Does it matter? No, as long as there's 2 branches there. I just wanted to point that out. Then where?
And then over 5, do the focus and do like down. Yeah, like that.
Okay.
And that's all.
That's all. Is he right? Alrighty, so Iverson. You were number 2, right? You two are the ones talking about it. Let's see if you two got this right. So talk to me through your condensed.
Alright, so I have CH3 and CH2, and then I have a C with 2 CH3s branching off of it.
So a C with 2. Did you do this?
Yeah, I did that.
Okay, that's cool. I think that would be acceptable. The thing you got to realize, and this is what I'm kind of struggling with, is it's multiple choice. So you got to kind of figure, you might have to do a little process of elimination there. You know what I mean? Okay, so I got that.
Then CH2, CH, and then branching off that CH is CH2, CH2, CH3.
Okay.
And then CH2 taken 4 times, and CH3.
Does that work? Just like that. Questions? Comments? Concerns? Funny anecdotes? Nothing. You guys got nothing for me. Tuesday morning, you got nothing. Yo.
Would it still be right if you put the 2 CH3 coming off the C together?
No. Great point. They're individuals. They've got to be separate. Great question. Alrighty. So, we need to talk briefly about something called halogenation. Now, we talked about this before, but I don't think we really understood it. Now, what you're going to have is halogenation of an alkane, obviously, is going to give you what is known as an alkyl halide. And what it is you take an alkane and you add to it a halogen. How do I know it's a halogen? Yeah, it's in the halogen group, which is in group 7 of the main groups, right? What's going to happen is you're going to get this. Let's say I take, it doesn't matter. Let's say I take CH3, CH2, CH3. This is what? Propane. I'm going to take propane, and I'm going to add to it, let's say I add to it chlorine, right? This is what happens. Chlorine splits up. You're going to get a Cl and a Cl. And it's literally going to trade the place of one of those H's. And you will get CH3, CH2, CH2, Cl. Just like that. And it doesn't matter which of those halogens it is. It could be F, Cl, Bri, doesn't matter. Any of them are going to do this. But notice, I only add what? One of them. Usually this happens in pairs, meaning I would take 2 alkanes, combine it with that, and each one of them are going to get one of them. Does that make sense? And that's what happens. There is like one question about this. But this is how we got, if you go back to last chapter, one of our functional groups was an alkyl halide. This is how they got them. Okay, and this is what changes it, or changes the properties of that alkane. Okay, remember how we talked about functional groups and they make it do different things? If you go back to the Fight Club article, that's what it talks about. That's what they do. They're trying to tweak it a little bit. You got a question, Cal? You were just what? If what was going to be on the test? No, I already put out Fight Club like the other day. Didn't I? Nobody noticed that? Huh. You might. You might. Just a thought. Okay. Alrighty, now, I want to do this. Now, there are a couple of questions that you really can't teach. Because what they're going to do is they're going to give you a name. They're going to say, is this a legit name? And they use this term, and we've used this, I've used this acronym earlier in the year. It's been a long time. Does anybody remember what IUPAC stands for? It's basically the people that set up the rules. Yeah.
That stands for International Union of Pure and Color Chemistry.
Did you remember that?
No, I had it written down.
Oh, you had it written down. Okay, yeah. So these are the people that make the rules up. And what a couple of questions they've done is they've given you a name. They say, is this a legit name? Okay? And so there's really no way to go through all the millions of combinations, right? So what I realized what I would do is I would draw that up. Draw that name and then see if there's a different way to name it that makes it better. Does that make sense? It's like, here's an example I wrote down, but then I used it, so I don't think it's going to work very well. So we went 5-propyl - 4-ethyl, no name, right? Now, some of these are pretty easy, you can notice right off the bat. Others you can't without writing it down. Okay, so is that a legit IUPAC name? No, why not? Yeah, because the E's got to come before the P, right? So that makes it easy. But when they do this, it's not quite as easy. So watch. We're going to go 3-butyl - 4-ethyl heptane. Okay? So that's it. And they're going to say, is this an IUPAC name? Which really just means, is this a legit name? I would draw this and then go back and see if there's a better way to name it, right? So Iverson.
Can you just see that butyl's 4, so it would have to be...
Okay, so that's things you can see, yes. Yeah. What I would do, if I was going to look at the big picture, I'd say, well, what's heptane? Heptane is 7, right?
Yeah.
Off my third, I've got a butyl. Right? Well, what did that immediately do to my backbone? It changed my backbone, right? So I know that that is now no longer a legit name. Do I really even need to go on? No, and a couple of these are straight true or false. Is this a real name? No, that's false. Because we've already realized that this is no longer a heptane. This is now really an octane now, right? So something like that. Does that make sense? So just kind of be alert. And what I've seen in the past, literally, I've seen all 4 drawn out. You know what I mean? They drew all 4 compounds out and then tried to rename it, which is not a bad idea, assuming when they shuffled it, you got A and not D, where you have to actually draw them all out. But that's really the best way to guarantee you're going to be correct. Does that make sense? Do we need to keep going here? Yes, Garrett.
Is ethyl heptane one word?
Yes, it is. I don't know why I left a space there.
Wait, but I don't understand. Why is that?
Okay, so if I did this, I'd have that, and then I'd have this, right? My 4-ethyl. Well, because now I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9. I've actually got a nonane here. It's not a heptane.
Oh, so the branching off counts as another one.
Yeah, well, so if I had drawn this, would we name it like that? No, so that's not a valid name. Do you see what I'm saying? They would have screwed up when they named that. And that's really the best way to answer those. I want to say there's 2 or 3 of them. Draw them out. Look at them and say there's no way that can be the proper name. Now what Garrett says is he sees obviously that this branch, I got a 4 branch coming off the 3rd carbon. That's impossible. Because that makes that branch longer than that branch, which means it's now got to be part of my backbone. And if you can see that, that's great. If you can't, name it. If your name's different than their name, as long as you're pretty confident, I'd say they're probably wrong. Okay, but there's no way to do that without just doing a few of them. I want to say on one of the homeworks, there's a question like this. Has anybody done either of the homeworks? There is a few. Okay. There's only 2 or 3 on the test, but there are some on there. Okay. Alrighty. So that's all I got. So let's see. Should we name some more cyclicals? Okay, so let's name this one. Let's go 10 hands. Name that. One, 2, 3. 4, 5, 6, 7, 8, 9, 9. One more. 10. Alrighty. What do you got?
Is it propylcyclohexane?
Propyl cyclohexane. He said, is it? I don't know. Is he right? Yeah. Why is there not a number there? There's only one, which means I would start numbering there anyways, just like X. Do we ever write 1X? No, we just write X. If there was 2 branches, then I'd have to number them. But that's a very good example, if you get my drift. Obviously, that's not the question, but it is a good example of the question. At least one of them. It's very specific. Okay? Alrighty, so, where we at? Besides Plain City. Anybody got any questions? We're all 100%?
I got some questions for the homework.
Go for it.
Okay.
Yeah, we got a few minutes. We still have time to work. Is this anybody's water bottle by the way? It looks really nice, and they left it in here the other day, and I hate to just chuck it.
Okay, so it says an alkane has 60 hydrogen atoms. How many carbon atoms would it contain if it were a straight chain alkane, a branched chain alkane, or a cycloalkane?
Okay, so straight chains are CX H2X plus 2. Always. It's a straight chain. H2X plus 2. Okay? If it's branched, it's usually, say it again, what were the options?
So a straight chain, a branched chain, and a cycloalkane.
And then a cyclo is usually CX H2X because I come back on myself and the 2 end H's are gone, right? And then a branched usually follows this same pattern. It just depends. These are 2. Let me think about that for a second. No, I think it fits the same. I think they're both, these are the same and that one's different. Because if you think about it, this one I simply take those end H's and they're gone and I fold it back on myself, right? These though, I think we demonstrated the other day when we did those 2 isomers of pentane, right? We did C5H12, didn't we? Right? And we did this one, right? Or we did this one, correct? Because if that's a C, I got C5, I still got 12 H's, don't I? So I think those 2 are the same formula, and then this one I know is different. I'm pretty sure that's the answer. I know those 2. I'm trying to think. It's just, there's so many options out there. I'm trying to think if there's any exceptions to this rule. But I can't think of any off the top of my head, so probably not. But I'm pretty sure that's it. And in the next chapter, we'll get into more of this stuff. So if I'm 60, I'm going to minus my 2, and then divide that by 2, right? So 58, 20, 29, I think. Does that make sense?
Yeah.
Okay. Anybody else? Or did you have another one?
I have a few, but it's not one.
Nobody else has done anything. You might as well break it out.
Okay. Let's have 15 minutes. Log in.
Well, then you can ask later. We good? Okay. Get busy.